So now that we've talked about the overall differences between concurrent and non-concurrent collectors, let's take a look at the collector API, and we'll talk about how it's implemented to enable different types of concurrent versus non-concurrent collectors. So it turns out the API for concurrent and non-concurrent collectors is identical. And in fact, it's a generic interface that has 3 generic types defined as part of the interface. T, as you might imagine, stands for type. So that's the type of object that are types of objects, or the object that's available in the stream that we're collecting. So you could have a stream of integers, a stream of strings, a stream of search results, whatever your stream is. So that's the type T. The A stands for accumulator, and that's the type of mutable accumulator object, what's called the mutable result container. And it's what we're going to be collecting into. And some common examples could be a list of T, a concurrent hash set, a map, a completable future of T, and these could be implemented all kinds of different ways. So array list, linked list, and so on. Very common to use array lists for this type of thing. Not always the case, but it's very common. And then finally, R is the type of the final result. This is what you want the collector to be collecting into. And this is typically something like a concurrent hash set, a list of items of type T, that's a very common thing, a completable future to a list of items of type T, et cetera, et cetera, et cetera. So those are the things that you are going to collect into. There are a total of 5 methods defined in the collector interface. The first one, which is perhaps the key one for this discussion about concurrent versus non-concurrent, is the characteristics method. And it basically provides metadata about the collector used by the Java Streams framework. And the Java Streams framework uses this internally for all kinds of good purposes, for optimizations and other features. One of the characteristics is unordered, meaning that the collector doesn't have to preserve the encounter order. And sometimes it doesn't matter. For example, for a non-concurrent collector for an array list or something like that, it's usually just as easy to have it be in encounter order as not, because it's coming from left to right. But for concurrent collectors and for other types of collectors, it makes a difference. A concurrent collector should be unordered, because it's not going to preserve order. But a non-concurrent collector can be ordered, or if you just leave it unordered, it'll order it anyway. Identity finish is an interesting characteristic that says everything that's done by the accumulator phase puts the final results into the mutable result container, and nothing needs to be done to it whatsoever. So there's no need for the finisher method to be called at all. It just becomes a no-op. It just returns null. And then the third method, or third characteristic, is the concurrent characteristic. This says the accumulator method, which we're going to talk about in a second, should be called concurrently on the result container, if it's set to concurrent. A concurrent collector should be concurrent, duh, but a non-concurrent collector should not be concurrent. Again, duh. If you have something as concurrent, the mutable result container must be synchronized some way. A very common thing to do is use a concurrent collection, like a concurrent hash map or a concurrent queue of some kind, and so on and so forth. For concurrent collectors, the combiner method is a no-op, because there is no combination. Everything is just accumulating directly into the mutable result container, and there's no need to merge stuff together in the final phase. So the combiner, you have to implement it, but it doesn't get called. And again, just to reiterate, you can use a non-concurrent collector either with sequential or parallel streams. And internally, the streams framework decides which collector to use based on, of course, the characteristics that you provide. Here's one way to set the characteristics. There's many different ways to do this, but one way to do it is to use enum set of, and then you can pass in whichever characteristics you want to have, or not. You can have none, have an empty set, and that will be what gets passed back here. There's other ways to do that as well. Okay, so let's talk about the other methods that are here. The first one is the supplier. This is a factory method that will create the type of mutable result container you want used by the collector. And a very, very common thing to use is array list : new, which is a constructor reference that when called will return a new array list. And so that's a very common thing to do. And again, remember that there'll be one of these suppliers created for every thread in the common fork join pool, because that's how things are going to get, subresults will be accumulated and then merged back together. So you might end up with multiple calls to whatever factory supplier you pass here. For concurrent collectors, you might pass back a concurrent hash set new or something else. And in that case, that'll be shared by all the threads in a stream, so of course it has to be concurrency aware or thread safe. The accumulator returns a so-called by consumer that will be used to add a new element to the existing result container. And a very common thing to use here, especially for non-concurrent collectors, is list : add. That's the method that takes a list and a new element and adds the item to the list. You don't need to have any synchronization for non-concurrent collectors, and list add does not have any synchronization, so it's perfectly suited for that purpose. For concurrent collectors, you may need to do something more interesting, and you may need to do something where you define what the accumulator will do. In this case, we're going to add an element to a set, and this will, of course, assume that this is done in the thread-safe way. The combiner returns a binary operator. So all these things are factory methods. They're making stuff that will then be used by the streams framework when it needs to combine stuff or accumulate stuff or make new mutable result containers and so on. And it returns a binary collector that merges two result containers together. So here's a very common one if we're working with lists. One would be a list of T, and another would be another list of T, and the combiner would take one and add all the contents of another to one and then return one. For some reason, there's no method in Java in the standard libraries that will add something and then return a reference to the thing that's been updated. So you have to write these kind of merge-like methods. It's always been annoying to me that they didn't add that. Remember, combiners are only used for non-concurrent collectors. Why? Because there's no combination in the mutable result container for a concurrent collector, because there's only one of them. So there's no need to combine anything. So it basically becomes a no-op. And then the final method, which is not used unless you have something special with your collector, is called the finisher. And that returns a function that converts the result container into the final result type. Oftentimes, it's either a no-op or it's the identity function. So you're just saying, just return the accumulator. It's got everything in it. There's no need to do any more transformations whatsoever. So if you set the identity finish characteristic, then you can return null and make it a no-op. However, there's other situations where finishers can be much, much more interesting. And we'll take a look at some examples as we go along. This particular one does all kinds of clever stuff to decide how to return a concurrent collector. And so the finisher is much more sophisticated than otherwise would be the case if you're doing non-concurrent collectors. Okay, so that's a quick overview of the internals of concurrent versus non-concurrent collectors.